Hello everybody. We're going to get some more work done here in our notes on trig ratios. I'm really excited about what I get to show you today in this video. One thing that we have not been able to do, and we're going to do for the first time, and I'll give you a peek here ahead of before we go back and fill that in here. Take a look at this triangle. Notice, we know two side lengths of this right triangle. Could we find the third? Absolutely, we could use the Pythagorean theorem to find the third. But one thing that we don't know how to do right now is to find these two acute angles. Well, if this is a right triangle and you know two side lengths, hey, you're going to learn a method today that will help you find this angle. Our calculator will be a big helpful part of that, so make sure that you have it out and ready, and I'll show you what you need to do there. All right, so what allows us to do this is called an inverse trig ratio. Inverse in mathematics are something that will undo something else. So if I have the sine of angle A is equal to x, by definition, angle A is going to be the, look how I write this, the inverse sine of x. So the sine with a -1 is called the inverse sine. Okay, it's not a negative first power, even though it kind of looks like that. That's not what this means in mathematics here. This is the inverse sine. Notice, with this, the angle goes in, and you get out a ratio. The inverse sine, what do you put into the inverse sine? You put in the ratio, and you get out the angle. So this allows us to put in a ratio and figure out what the angle is. If the sine of angle A equals x, then the measure of angle A is going to equal the inverse sine of x. Don't call it the sine -1 of x, call it the inverse sine, please. There is another term you might see sometimes where it's referred to as the arc sine. That's the same thing as this. We're not going to use that terminology in here. All right, if the cosine of angle A equals x, then the measure of angle A is going to equal the inverse cosine of x. And if the tangent of angle A equals x, then the angle measure is going to equal the inverse tangent of x. So we can use the same ratios. We're just using them backwards to figure out what the angle is, and our calculator is going to help us do that. So let's look at that first example down here. Find the measure of angle A to the nearest tenth of a degree. All right, so we've got our angle. Just like before, it depends on the angle that you have. It's in reference to the angle. Look at the two sides we have. 16 we know is the opposite. 20 we know is the adjacent. So just like before, we're thinking SOHCAHTOA. Opposite and adjacent is the tangent. So what do I know in this situation? I know that the tangent of angle A is equal to opposite 16 over adjacent 20. We want to figure out what this angle is. Now, one thing we should probably do, this isn't a must, but I definitely need to do it if I see it. I'm going to reduce that, right? That's 4/5. So the tangent of angle A is equal to 4/5. That's the ratio. From what we just learned here, if the tangent of A equals x, then A equals the inverse tangent of x. Angle A is going to equal the inverse tangent of this ratio. A equals the inverse tangent of 4/5. So how do we know what this angle is? We grab our calculator now. Just like we can use the sine, cosine, and tangent buttons to figure out what a ratio is, we can use the inverse sine, inverse cosine, and inverse tangent buttons to figure out the angle. I'm going to see the inverse tangent right there, the tangent with the -1. So I need that's in blue, so I'm going to use the second power, or the second button here. The second, and I choose that. All right, here we go. Try again. So second tangent pulls up the inverse tangent of 4/5. Let me double check my mode. Okay, I'm in degrees. I'm good still. The inverse tangent of 4/5, it's about 38.7 degrees. Isn't that cool? Right? Those two side lengths, and now we know this is 38.7 degrees. That should look reasonable to you. It looks reasonable to me. All right, let's try this one. I'm still searching for, directions were for the measure of angle A, so this is my angle up here. All right, opposite hypotenuse. We should recognize that as the sine. The sine of angle A is equal to 7 over 11. That doesn't reduce, I'll just leave that alone. All right, if the sine of A equals 7 over 11, A equals the inverse sine of 7 over 11. Type that in my calculator. Second, see the inverse sine, 7 over 11. It's about 39.5 degrees. Does that look like a reasonable angle measure for this triangle? I think it does. Okay, let's look at one more of these. There's my angle. This is the adjacent. This is the hypotenuse. Adjacent and hypotenuse tells us cosine. The cosine of angle A is equal to adjacent 10 over hypotenuse 16. Okay, again, you don't have to do this, but I'm going to reduce that. That's 5/8. If the cosine of A equals 5/8, A equals the inverse cosine of 5/8. I'm back to my calculator. Inverse cosine, oops, 5/8. About 51.3. Yeah, that makes sense. Looks right to me. There we go. Okay, now I'm just peeking down here at the directions. It says solve the right triangle. What does it mean to solve a right triangle? Well, glad you asked. It said way up here. Back to our vocab. Okay, to solve a right triangle means that we need to, well, what do you think we need to know? It means we need to find all side lengths and all angle measures. Okay. So whenever you hear solve the right triangle, it means I want to know everything about it. All the side lengths, all the angle measures. So you saw the directions for the next couple problems that we're going to do. Okay, let's head back down there. Solve the right triangle. Finding missing side lengths, missing angle measures. So we can pick wherever we want to start. Notice I know, of course, that's a right angle. I know this side, I know this side. I've got one side missing, and I have two angle measures missing. Well, what do we want to start with here? I tend to start with just the one item that's missing, which in this case is this side length. Now, how can I find this side length with the information I know? I can't use sine, cosine, or tangent because I don't know one of these acute angles. But I recall that if I have two sides of a right triangle, I can find the third from the Pythagorean theorem. So we've got 12 squared plus 17 squared equals c squared. See, that's 144. 17 squared is 289. Okay. Add those together. I've got 433. going to take the square root. I'm not aware of any perfect squares that go into that. I get C is about square root of 433, 20.8. Now, just to be clear for everybody, I'm going to, instead of calling that C, I'm going to call it what it is. I'm going to change that now to be, that's PN. So there's my missing side length. 20.8 to the nearest tenth. Now I'm going to find my angle measures. How do I do that? Well, what were we just working on? Using our inverse trig ratios, right? So let's start with angle P. If this is my angle, what two sides am I going to use? I'm not using 20.8, that's for sure. That's a rounded number. Stay away from that. I'm going to use the opposite and the adjacent. So now this turns into exactly what the previous problems were. Okay, the tangent of P equals 17 over 12. P equals the inverse tangent, 17/12. P is about, I'm typing that in my calculator right now, 54.8 degrees. Okay, so I've got that. Now I'm going to find angle N, which means I have to rename my sides. Now this is the opposite, that's the adjacent. The tangent of angle N is 12 over 17. N is the inverse tangent of 12/17, which is about 35.2 degrees. There we go. Both missing angles. Our missing side. I know everything about that triangle. Okay, now there's decision making that needs to happen when we approach a triangle. The information I have in this triangle is different. Instead of knowing two sides and neither acute angle, in this one I know one side and one acute angle. I'm going to start with the easiest thing on here. Hey, what's the easiest thing to find? Either one of these missing sides? I would say the easiest thing to find is this missing angle right here. Hey, 180 minus 70 minus 90, this was pretty easy. Hey, we've got U is 20 degrees. So like that, I'm a third of the way done. Now I'm going to find missing sides. Okay. Let me call this X. All right, how am I going to solve this? Can I use the Pythagorean theorem? Certainly not. I don't have two other sides, I only have one other side. Is this a special right triangle? Nope. Okay, but I do know the acute angle, so I'm going to use trig. I can pick either the 20 or 70, either one, neither of them are rounded. Let's say I pick the 70. I've got opposite and hypotenuse. Okay, so sine of 70 degrees, nothing new here. X over 15, multiply by 15. $15 times the sine of 70 degrees, and my calculator tells me that's about 14.1. So let me change that. That's UT 14.1. And now TS. Let me call that Y. I'm still using this angle, adjacent hypotenuse. Okay, that's cosine, of course. The cosine of 70 degrees equals Y over 15. Multiply by 15. Gets me about 15 cosine of 70 degrees. That's about 5.1. And that's TS. And look at that. I know everything about that triangle. So there you go. Inverse trig ratios, solving right triangles. We now know something we didn't know before this video. Thanks.